Hello everyone. So today we will be discussing about the developments that led to the Bohr's model of atom. Okay, so firstly we will be studying the wave nature of the electromagnetic radiations. Okay, we will be studying the electromagnetic radiations and their properties. So what are electromagnetic radiations? The basic funda behind electromagnetic radiations is that they are produced when there is an accelerating charged particles, which means that there is a charged particle which is moving. Now this moving charged particle will produce simultaneously electric and magnetic fields. Okay, and this all together is known as electromagnetic radiation. Now, as I have said that in the second point, Maxwell suggested that when electrically charged particle moves under acceleration, alternating electrical and magnetic fields are produced and transmitted. So, as I said, that whenever there is a charged particle and it is under acceleration, it will produce simultaneous electric and magnetic fields. Also, the oscillating electric and magnetic fields produced by oscillating charged particles are perpendicular to each other and to the direction of the wave, we can say. Now, as you can see in this diagram, that the electric field and the magnetic field both are perpendicular to each other, and also they are perpendicular to the direction of propagation of the particle or propagation of the wave. Now this says that whenever a particle is under acceleration, it is producing alternating electric and magnetic fields, and these two fields, the electric and magnetic fields, they are perpendicular to each other. Okay, and they're also perpendicular to the direction of propagation, means in the direction in which the particle is accelerating. Okay, so all these three things are perpendicular to each other, and this is shown in this diagram. Now, there are some properties which these electromagnetic radiations possess, and the very important property of these electromagnetic radiations is that they do not require any medium to travel in vacuum. Okay, no medium is required and they can travel through space or vacuum. Okay, also they are actually characterized by many physical quantities, I must say, like frequency, wavelength and wave number. I will be discussing these things or these topics in the next slide. And again, when they travel in vacuum, this is again another property of them, they travel with the speed of light. Okay, and the speed of light we take as 3 into 10 to the power 8 meter per second. Now there are different kinds of electromagnetic radiations as shown in this figure. Okay, and they are actually have different range of their wave number and wavelength and frequency as shown in the table. For example, we all know in Vibgyor, right? Red color have the longest wavelength, and wavelength and frequency both are actually inversely related. I will be explaining this again in next few slides, so wait till then. But if we look at this figure, then we can see that as we move across this table, the wavelength is increasing and the frequency is decreasing, and there are n number of electromagnetic radiations that we can see here. There are gamma rays, x-rays, UV visible, microwave, etc., and they all have their own purpose. Okay, so these you will be studying in higher studies, or if you wish to know about them more, you can go through some reference books like Pradeep, etc. I'll just give you the basic idea. Like, x-rays are used for x-rays that are done in hospitals, and your UV, visible, etc. are used for your spectroscopy that you will be studying in higher studies. The like we actually find out the structure of the organic molecules, and sometimes the functional groups that are there present in the organic molecules with the help of these UV and visible radiations and spectras. There are devices called UV visible spectrophotometers, and microwaves are used in, obviously in the microwaves they are used by to heat up the food. Okay, to so that we can eat hot food and not the cold one. Then there are radio waves, etc. So there are so many waves you can study about them, but as per the syllabus, if we look at them, then and the chapter in NCERT, so you have just to learn about the electromagnetic radiations for now and their properties. Okay, so now let's study about frequency, wavelength, and wave number. Now, frequency is nothing but when an event actually repeats itself in a particular unit of time, then it is known as its frequency. For example, a person is drinking 20 glass of water in a day, then his frequency of drinking water in a day is 20 glass. But other person, if he is drinking 12 glasses only, then his frequency is 12. Okay, so this is frequency. It is denoted by mu and its unit is per second or hertz, hertz, and it is represented by h and z altogether, or maybe second inverse. Okay, so if in question it comes like second inverse, then it is frequency, and if it is hertz, then also it is frequency. So please don't get confused in numericals. There are two units. Okay, now comes wavelength. Wavelength, when we see graphs of the waves. Okay, how are they? Like they are like, there are crust, there are troughs, crust, trough, crust, trough. Now the distance between the two consecutive crust, or maybe two consecutive trough, is known as your wavelength. I have shown this thing in a diagram. On the next slide I will show you that. And wave number is nothing but the inverse of the wavelength, and it is denoted by mu bar. Wavelength is denoted by lambda. Unit of wavelength is actually, it's actually length, so it has the units of length only, that is meter, etc. But actually it's a smaller quantity, so it is in almost nanometers and armstrongs. So yeah, please keep this thing in mind. Then wave number, as I told you, it is inverse of wavelength, and here are the formulas given. Mu bar is equals to 1 by lambda, or lambda inverse, and the relationship between frequency and wavelength is given as c is equals to mu lambda. Okay, c is here what, your speed of light, that is 3 into 10 to the power 8. Now this formula shows that we can write lambda is equals to c by mu. So this shows that if lambda is increasing, then mu is decreasing, means wavelength increases, your frequency decreases. And this signifies that they are inversely proportional. Please keep this thing in mind, because it's going to help you in future. Okay, so this is the graph I was actually talking about. If you look at the graph that is on the second number, we can see that the number of times it is getting repeated is actually more than the first one. So the frequency is more in the second, while you can see that the distance between two consecutive crusts is less in the second one, and more in the first one. So wavelength is short in the second one. So automatically I told you, like, if frequency is higher, so wavelength will be lower. So it's actually the common sense. So this is how we see the graphs. Okay, now you can see two numericals. These are from NCERT. You can practice them very easy, right? You just have to apply the formula c is equals to mu lambda, and uh, either of like from the three of them, only two of them will be given, and the third one you have to find out. So it's very very easy. I think like it's fifth or sixth standard maths, so it's easy to calculate. You can try them, and the answers are also on the screen. Okay, so let's move on to the next slide now. So, till now we have studied the wave nature of the light, we can say. Okay, wave nature we were studying because electromagnetic radiations give us the idea of the wave nature. Now we will be studying the particle nature of the electromagnetic radiations. So we will start it with the black body radiation. It's a very interesting topic. Let's dive into it. So what it says that when a substance is heated, it emits radiations. But these radiations are actually not of same wavelength or frequency. But as the temperature keeps on increasing, the wavelength and frequency of the radiations that are being emitted keeps on changing. Now, how it goes on to change and what happens to the wavelength and frequency of these radiations that are being emitted by a substance on being heated at different temperature? Let's see. Okay, so here's a very good example of iron. When iron is heated, it turns first red. As it is heated more, temperature might be increased. It turns to white and then blue. Now we can clearly see that we all know that red has very high wavelength. Okay. Now when it goes from red to white and then to blue, this shows that the wavelength is decreasing, and wavelength decreasing means frequency is increasing. So you have to keep this point in mind that as temperature increases and the radiation is being emitted by a substance, then what happens to those radiations is that the frequency of those radiations is increasing because the wavelength is decreasing. Okay, you can keep in mind the example of iron. Now, what's the statement of black body radiation? Please look at the last point. The ideal body, which emits and absorbs radiations of all frequencies, is called a black body, and radiation emitted by such a body is called black body radiations. These two last points are very important. One is the statement, and one is the conclusion that we derived, that as the temperature keeps on increasing, the wavelength of the radiations that are being emitted by the substance that is being heated goes on decreasing, and the frequencies goes on increasing for those radiations. Let's move into the next slide now and see what's there to study. Okay, so I actually had to discuss this graph. It is from NCERT only. Okay, now if you look at this graph, how will a normal person read this? Okay, he will go from 0 to 3000 while reading, right? But we don't have to go from there. We have to go from 3000 to 0. Why? Because I already discussed when a body is being heated, the wavelength is decreased and the frequency is increased. So we have to start from the higher wavelength to the lower wavelength, right? Because the final wavelength will be the lower one, not the higher one. So when we start from 3000, what do we see? That as the wavelength goes on decreasing, as the wavelength goes on decreasing, the intensity is increasing till a particular point, and further to it, when the wavelength is decreased, the intensity also goes on decreasing. Okay, so look at the second point on this slide. At a given temperature, intensity of radiation emitted increases with decrease of the wavelength. When the wavelength is being decreased, this means that when the wavelength is being decreased, the radiation intensity of radiation emitted is increasing, but it reaches a maximum, and then when further the wavelength is actually decreased, the intensity also decreases. So this was the graph that I had to explain, and it is very important. Please learn these points and remember this graph because it is sometimes asked in the exam. Okay, and yeah, let's move to the next slide now. Okay, so now we will be doing the Planck's theory. Now what Planck said, that atoms and molecules could emit and absorb. Okay, they could emit or absorb energy that is quantized, right? Quantized means that is fixed. Means the values are actually fixed, right? There is a specific interval after which the values will come. For example, I will give you an example. The energy that can be absorbed and released is always minus 13.6 into z square upon n square ev per atom. This is quantized value, and this is calculated by Niels Bohr, and in the Bohr model of atom, which we will be discussing in the next video. Today we are only doing the theories that led to the Bohr model of atom. Okay. Similarly, he said that angular momentum is mvr equal to nh upon 2 pi. Right now I'm just telling this formula, please don't get confused. I'm just giving you an idea. Now nh upon 2 pi, this h upon 2 pi and h upon 2 pi is the multiple. This is a multiple, and it is a particular mathematical value, and the angular momentum will always be a multiple of this value. ठीक है, मतलब इससे ना आगे ना पीछे, बट इसका एक मल्टीपल होगा. अब n की वैल्यू क्या होगी? 1 2 3 4 5 6 7 8. ये इसमें एच अपॉन टू पाई का एक पर्टिकुलर मैथ का वैल्यू आएगा, मैथमेटिकल वैल्यू आएगा, वो उसमें मल्टीप्लाई होता रहेगा. एक रैंडम वैल्यू कभी आ ही नहीं सकती है, ये हमेशा एक फैक्टर होगा एच अपॉन टू पाई का. सो दिस इज द quantization of angular momentum. Similarly, energy is also quantized. ओके, सो प्लैंक ने यही कहा था कि आपकी जो एनर्जी रहेगी वो हमेशा क्वांटाइज्ड रहेगी, ये कंटिन्यूस नहीं हो सकती है, ये डिस्क्रीट होती है. He also gave the name quantum to the smallest quantity of energy that can be emitted or absorbed. So, what is quantum? It is the smallest packet of energy that can be emitted or absorbed in the form of electromagnetic radiation by any atom or a molecule. Okay, please remember these terms: quantum, quanta, your discrete, and difference between discrete and continuous manner. Okay, now he gave an equation: E is equals to h mu, where E is the energy of the quantum of radiation that is being absorbed, and your mu is the frequency, obviously. And the representation of the Planck's theory's formula is E is equals to h mu, where E is energy, mu is frequency, and your h is called as Planck's constant. Very important term, Planck's constant. What is Planck's constant? That you are seeing on your screen right now, it is represented by h, and its value is 6.626 into 10 to the power minus 34. This value will not be given in the questions in your paper anywhere. You have to just memorize this value, and its unit is joule second. Okay, not joule per second, joule second, and the value is 6.6 into 10 to the power minus 34. Forget about this 2 6, just 6.6 into 10 to the power minus 34. Please remember this value, it's a very important thing in this chapter. Okay, so now we will be studying photoelectric effect. Now, photoelectric effect generally says that there is an electron, for example, which is present on the surface of any metal. Okay, now that will be ejected as soon as any kind of radiation will strike it. Okay, so electron ejection takes place as soon as any kind of radiation strikes it. Now, this ejection of electron actually is a very simultaneous process. रे आएगी और इलेक्ट्रॉन निकल जाएगा. ऐसा नहीं है कि that there will be a time difference or time gap between these two processes. No, it's not like that. It is very simultaneous. Now, what happens that there is a minimum frequency value that should be met, or energy value that should be met by the radiation that is going to strike the electron, then only ejection will take place. Okay, मतलब ऐसे random नहीं होगा. There will be a required value, जिस अगर वो met होगी तभी आपका इलेक्ट्रॉन जो है वो इजेक्ट होगा, अदरवाइज नहीं होगा. एंड दैट मिनिमम फ्रीक्वेंसी ऑफ दैट रेडिएशन रिक्वायर्ड इज नोन एज your threshold frequency, and that energy is h mu naught. Mu, it is represented by mu naught, as you can see in the third point. And the h mu naught, that is the energy that is required, is known as work function. It is represented as phi naught. I will be explaining it further in the next slide. Okay, so let's go through the second and third point. The second point says the number of electrons ejected is proportional to intensity or brightness of light. Now, okay, now it is these two points are very important. First, that the number of electrons that are being ejected, that is directly proportional to the intensity of light. Okay. Also, the kinetic energy, it does not depend upon this intensity. It depends only on the frequency. Okay, the kinetic energy of these electrons increases with increase of frequency of the light used. So there are two things: the number of electrons that are getting ejected depends upon the intensity, while kinetic energy only depends on the frequency and not on the intensity. This question is asked actually many times in the paper, that सिंपल स्टेटमेंट आ जाती है लाइक काइनेटिक एनर्जी डिपेंड करती है क्या इंटेंसिटी पे या नहीं. ठीक है, या फिर काइनेटिक एनर्जी किस पे डिपेंड करती है. तो आपको बताना होता है कि दैट इट डिपेंड्स ऑन फ्रिक्वेंसी एंड नॉट ऑन द इंटेंसिटी. इट इज़ वेरी इंपॉर्टेंट. एंड द डिपेंडेंस ऑफ काइनेटिक एनर्जी ऑन फ्रिक्वेंसी you will be seeing in the next slide. Okay. So we know that we studied in the previous slide, right? That number of electrons depend on the brightness or intensity of the radiation, and kinetic energy does not. So what happened that later it was found out, or I should better say, like Einstein actually explained the photoelectric effect on the basis of Planck theory. What did he say? What was the relation? E is equal to h mu in Planck's theory. We studied that relation, right? He used this relation to actually derive the kinetic energy, etc., for this photoelectric effect. Okay, and he proved that how kinetic energy was dependent on the frequency. Okay, so let us revise two things. Kinetic energy depends on frequency, and intensity. Your number of electrons ejected depends upon intensity. Okay, remember these two things. Now let's see how kinetic energy depends on frequency. So what Einstein did, what he said that, for example, any your photon is approaching the electron on the metal surface. As soon as it approaches, the electron will be ejected out simultaneously, and what will happen? The energy transfer will take place. Okay, now how will that energy transfer take place? Let's see that. So photon's energy is h mu. Now when it strikes the electron, your electron requires work function, that is h mu naught. Now it requires the work function h mu naught. So h mu is equals to, for now, h mu naught. Okay, but when electron will be ejected, it will have some kinetic energy. So kinetic energy is half mv square. So according to the law of conservation of energy, your h mu, that was the energy of photon, is converting into two energies. One, the energy that was required for the electron to get ejected, that is work function, your h mu naught, and the kinetic energy that it is getting after being getting ejected. Okay, so h mu is equal to h mu naught plus ke, and from this we can say that your kinetic energy depends upon frequency. You can see the formula in the last point, that kinetic energy is h mu. Kinetic energy's expression is h mu is equals to h mu naught plus half mv square. And from here, see the second last point, your kinetic energy can be calculated as h mu minus h mu naught. These two formulas are very important, and you should know that how to use these formulas in numericals. You should be aware of these. There are three terms. One is h mu. This h mu is the your energy of the photon. Your h mu naught is the work function, and half mv square is your kinetic energy. So this is the relation between the three terms. Please remember it. Okay, and the two statements that I told, that the number of electrons ejected depends upon the intensity, while the kinetic energy depends upon the frequency. Now let's see some numericals in the next slide. So here are some numericals. Okay. So first is, when electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium, the electrons are emitted with kinetic energy. What is the minimum energy needed to remove? Okay. सो दे आर सेइंग दैट आपके पास उन्होंने काइनेटिक एनर्जी दे दिया, ठीक है। अब आपको उसमें से मिनिमम एनर्जी जो इलेक्ट्रॉन को इजेक्ट होने के लिए चाहिए वो निकालनी है। तो अब आपको फॉर्मूला पता है, के ई इज इक्वल्स टू एच म्यू माइनस एच म्यू नॉट। अब इसमें मिनिमम एनर्जी क्या होती है? एच म्यू नॉट होती है, दैट इज़ योर वर्क फंक्शन और एनर्जी करस्पॉन्डिंग टू द थ्रेशोल्ड फ्रीक्वेंसी। आपको वो निकालनी है। तो आपका फॉर्मूला क्या बन जाएगा? के ई इज इक्वल टू एच म्यू माइनस एच म्यू नॉट। आपको एच म्यू नॉट निकालना है तो उसको इक्वल्स टू के उस साइड ले जाइए, के ई को इस साइड लेकर आ जाइए, तो एच म्यू नॉट इज इक्वल्स टू एच म्यू माइनस के ई। ठीक है, ये आपका फॉर्मूला है। अब इस फॉर्मूले में आपको एच म्यू नॉट नहीं दे रखा है, आपको के ई दे रखी है, बट देर इज़ अ ट्रिक, यू कैन फाइंड एच म्यू। एच म्यू क्या है? आपकी रेडिएशन है, मतलब एनर्जी जो गिर रही है, सॉरी हाँ मतलब रेडिएशन जो गिर रही है उसके करस्पॉन्डिंग एनर्जी है। आप उसको निकाल सकते हो इजीली, आई गेस। कैसे निकालोगे? E इज इक्वल्स टू एच सी बाई लैम्डा। आपके पास वेवलेंथ दे रखी है ना उस रेडिएशन की, तो आप उसमें से फ्रिक्वेंसी निकाल लो। आप फ्रिक्वेंसी निकाल लोगे तो एच म्यू भी आ जाएगा। तो बस फिर दोनों निकाल के आपको सब्सट्रैक्ट करना है। वेरी इजी क्वेश्चन। द नेक्स्ट क्वेश्चन इज, थ्रेशोल्ड फ्रीक्वेंसी इज गिवन, म्यू नॉट दे रखा है, कैलकुलेट काइनेटिक एनर्जी एमिटेड व्हेन रेडिएशन ऑफ फ्रीक्वेंसी म्यू। अगेन वेरी इजी क्वेश्चन। आपके पास म्यू दे रखा है, म्यू नॉट दे रखा है, के ई निकालना है, तो क्या होता है? एच म्यू माइनस एच म्यू नॉट। वेरी इजी। Acha, there is this part in 2.8 which is, what is the maximum wavelength that will cause a photoelectron to be emitted? Now, maximum wavelength यानी कि मिनिमम एनर्जी जिससे आपका फोटो इलेक्ट्रॉन एमिट होगा। तो मिनिमम एनर्जी यानी कि और वर्क फंक्शन की एनर्जी, ठीक है, तो वो उसी के करस्पॉन्डिंग जो वेवलेंथ होगी वो मैक्सिमम होगी, क्योंकि एनर्जी और वेवलेंथ आर इन्वर्सली रिलेटेड। लुक एट द फॉर्मूला। E is your lambda is equal to hc by E, और here you can see like energy is equals to h में होता है. तो अगर एनर्जी फ्रिक्वेंसी के डायरेक्टली प्रोपोर्शनल है तो फ्रीक्वेंसी इन इटसेल्फ इज इन्वर्सली प्रोपोर्शनल टू वेवलेंथ, राइट. तो एनर्जी भी लैम्डा के इन्वर्सली प्रोपोर्शनल होगी. तो अब वो कह रहे हैं आपको मैक्सिमम वेवलेंथ निकालनी है जिससे आपका फोटो इलेक्ट्रॉन निकलेगा. अब मैक्सिमम वेवलेंथ के लिए आपको मिनिमम एनर्जी निकालनी है. तो मिनिमम एनर्जी आपको ऑलरेडी पता है क्या होती है. मिनिमम एनर्जी थ्रेशहोल्ड फ्रीक्वेंसी के करस्पॉन्डिंग वाली एनर्जी, दैट इज़ योर वर्क फंक्शन. और आपने वर्क फंक्शन शायद निकाला था या फिर दे रखा था. हाँ, आपने वर्क फंक्शन ही निकाला है क्वेश्चन में. आपका ये जो 3.84 का वैल्यू है, राइट. तो बस इसके करस्पॉन्डिंग कैलकुलेट करके आप अपना वेवलेंथ निकाल सकते हो. Okay, so this slide says that your light have dual nature and you guys already proved it, right? कैसे प्रूव किया आपने? ब्लैक बॉडी रेडिएशंस देखी, उसने क्या प्रूव किया? आपका वेव नेचर प्रूव किया कि किस तरीके से मैटर्स में से डिफरेंट डिफरेंट वेवलेंथ की आपकी वेव्स निकलेंगी जैसे वो हीट होगा. तो वो आपका वेव नेचर एक्सप्लेन कर रहा है. जबकि फोटो इलेक्ट्रिक इफेक्ट क्या कर रहा है? इट इज़ एक्सप्लेनिंग द पार्टिकल नेचर. आपका इलेक्ट्रॉन रिजेक्ट हो रहा है जब आपका फोटोन उस पे अटैक कर रहा है. So all these studies that you already did like Planck's theory and photoelectric, that was like your पार्टिकल नेचर, राइट. तो आपने वेव नेचर भी एक्सप्लेन किया, आपने पार्टिकल नेचर भी एक्सप्लेन किया. तो इन चीज़ों के बेसिस पे हमने कहा कि जो लाइट है वो उसका दोनों का इनका नेचर है, वेव नेचर भी है और पार्टिकल नेचर भी है. एंड लेटर ऑन इट वाज एक्सेप्टेड एंड till date we accept that light has dual nature. Okay, so there is nothing much to explain. And so I guess thank you everyone. And yeah, I would like to recommend you guys to Pradeep's chemistry. Please try to solve questions from that book. There are very good examples. And although if you do NCERT properly, all the solved examples and the questions in the back, then I think that's more than enough. But yeah, if you have to go for higher studies, right, please try to solve the questions, which is because this is very important chapter. And chemistry more or less remains same. Your basics should be clear. So try studying reference books. You have plenty of time. Abhi you are in 11th and 12th. So do it. Thank you.